Hello guys, hello Romania and the rest of the world. This is Anish here from HCL Technologies. I'm a solution architect, platform owner, platform product owner, Scrum Master and a DevOps Evangelist. Thanks to life that it has given me so much of experience doing multiple roles. I'm here to be with you guys today. Good afternoon once again. And hope you guys enjoy the session today. Okay, I don't see how many of you are there on the call, but I hope I'm loud and clear. Today, on today's topic, if you're a developer on the call, you might go back with knowledge to see how important it is to claim your developer experience. If you've been having tough time developing, if your experience has been really rough all this time, it is important that you speak up and you know that you have enough to do, or you have enough things in the market for you to help your improve your developer experience. On the other side, if you're a product owner, if you're a business owner, or if you're a platform architect, it is important for you to understand how a developer experience affects your users directly or indirectly. It is very important to look into this aspect, and I hope this session gives you that insight and helps you do that. So on today's agenda, we are going to talk about intrinsic topic. We are going to go into each of these topics, but on the whole, we are going to talk about how we did development then and now, shift left development approach, how it affects your developer experience, and how improvising developer experience helps you to build more features and deliver it to production faster, and also a few simple demos. Okay. Okay. So I started my career as a software developer. I've been a full stack developer or a Java developer for quite some time, for quite a few years. And I very well remember how things happened then. If you are a new generation developer, probably you wouldn't understand how the waterfall model worked, how we package our stuff. But if you are from my times, you will understand how things work then. It used to be really cool life. If you're passionate for coding, all you did was only coding, nothing more than that, right? You understand your requirements, you write your code, you test your code, you package it into a jar or an NPM file, and you send it to your release management team, and they take care of putting it into production, and you're finished. You then pick up your next requirement. It will happen for three month cycle, 6 month cycle, and whatever. Life used to be really good. But growing demands, but growing demands, then there came agile way of development. Because the features that has to be released in the competitive world was getting very delayed, and so they wanted a faster loops or faster iteration of software development, and that demanded a different way of working altogether. We needed agile, we needed Scrum teams, we needed then it introduced the microservice architecture, where you develop where you develop a very decoupled or loosely coupled distributed application, which then introduced your Kubernetes. Actually, Kubernetes blew my mind. Probably a lot of people on the call today will agree to that, of how a complex architecture or complex infrastructure is put together. The moving parts of the infrastructure is put together to simplify things or to keep things in control in a containerized world. So with all this introduction, we had it actually added a lot of pressure on the developer, because now it is the developer should not just only focus on the requirements, but on a lot of other stuff, right? I'll talk about that a little later. But if you look at then what happened is, because of this kind of development, there's a lot of issues that were introduced feature-wise or anything else, and that actually cost you a lot. Like you see this simple graph here, it's quite understandable. Anything that you spot right in the right on the request phase, right, it costs you probably $1. But if the same issue is not identified, if it is identified after you release, it costs you at least 150 times of what costs you when you identify in the request phase. So that is the reason we emphasize shift left approach of development, so that you identify things quite early in your development life cycle. So with that idea, the developer's responsibility is increased, because now it is not just he has to focus on his development activities, but also he has to focus on how things are developed, how it is, how it is related to the other teams. So that with an expanded developer responsibility and the growing microservice architecture, the number of tools that came into the market, if you look into CNCF's cloud space, right, it is quite overwhelming. With these boxes become smaller every day. So with that, again, the developer now has to focus, he has to do a lot of new learnings now, apart from the languages that he works on, apart from the frameworks that he or she works on. Now they are responsible for running your code as well as of bunch of other stuff to learn, right? For example, the Kubernetes world, you have to know what is a deployment, what is an ingress, what is a service, how does it affect the resource allocation, and not just that, but also as the complexity increases more and more, where you have to understand how observability works, how your canary deployment works, how you should code for health checks. You need your health check endpoints so that your pods know how to know if your application is healthy. So there is, I would split a developer's time into at least 60 and 40, where 60% of time is spent on focusing on your requirements, 40% of time is spent on how you package your application, which is quite overwhelming. Right, so what do we do? We can do a number of things. So first, we understood the situation. So what we did is we thought we could educate the users. The developers, we give them training materials or whatever. But if the learning pace or the knowledge level of the developer can't be assured to be at the same level, because people learn at a different pace. They can be slow learners, fast learners, and the situations are different. So education only cannot be a solution. Yeah, of course, it helps you to understand, but it only can't be a solution. And that is when we decided, let's see how we can externalize all these things to a different platform, so that we can give that as a solution for multiple teams at enterprise level. But it helps to a certain extent, but every team has their own requirement. Every team has their own deadlines, right? You can't cater to every single requirement with the same solution. The same t-shirt size doesn't fit all. So of course, education and the platform engineering team are contributing in improvising the situation. But again, you have to shift a little left and see what else can you do, right? This is where I say you have to empower your developers or enable your developers with the necessary tools and the practices, right? And that is where I would like to talk about local dev environments, personal dev environment, and the developer control plane and observability at the developer level. On this call, I'll be focusing more on develop local dev environment and the personal dev environment. And probably I'll touch upon the 3 and 4 a little bit, not more, but a little bit, right? So, but I'll tell you why it is important to improve the developer's experience. It is, if you look into the Google Accelerator state-of-the-art state of DevOps research, DORA research report, it clearly says that with the surveys that they have taken, improving your or empowering your developer or improving your developer experience directly impacts the speed in which you deliver features to your users. You can see the numbers here. You have more frequent deployments, you have lower lead time, you have faster recovery from incidents by doing all these things. So it is very important for you guys to understand how that developer experience is very important. Okay. So what is shift left, right? Shift left is very easy to understand. So whatever you do on your CI/CD pipeline, whatever you do after your code is merged, on your code or on your artifact that is going into production, whatever you do on your artifact that goes into production in different stages, you try to do all of them or most of them during your develop phase or during your plan phase. Okay. Um, so that is shift left development. And within the continuous build, in the containerized world or in the microservice architecture world, within the containerized continuous build, there are multiple stages again. Okay, multiple stages where you have to build your artifacts, you have to test your artifacts, you have to tag it, you have to render your manifest files, and you have to deploy them to your cluster and then tail the logs or do debugging or whatever. So within the continuous build world, on a containerized world, there are multiple stages, right? So, and again on the continuous integration things, there are multiple things that you want to do. Depends on the project. You want to do quality check, unit testing, container scanning, compliance testing, dependency scanning, etc., etc. There are multiple things. But so, how do we shift left all these things? Is something that we're going to discuss. So, I would like to put it on a protractor. If you like geometry, I was a geometry buff as a kid, so I would like to put that on a protractor and see how and try and see if it could make it more understandable to see what shift left exactly means, right? So on a protractor, if you see at a 90-degree, right, whatever you do at 90-degree, I say that this is exactly the point when you merge your code into your master branch. And anything that you do on your artifact before it goes to the release is something that you're doing on your right? And anything that you manage to do on your artifact before the code is merged to your master branch is on your left. That is, from my experience, it is debatable, but from my experience, this is something that has helped me. So anything that you can manage to on your artifact before the code is merged to the master branch is your shift left development approach. Within the shift left development approach, anything that you are able to do on your local dev environment or at 0-degree, which is not on an environment, not on your cloud, but on your local machine, is your local dev environment. And anything that you can do on your own environment, you have your own dedicated environment, is a personal dev environment. So these are the two things that I would like to focus in the next few slides. So it's important, before we get into the local dev and the personal dev environment, it's important to understand about this inner dev loop. Okay, I thanks to Ambassador. I picked a cue from them. It was a very interesting read. So it's very important for the developers, for the platform engineers or the platform owners, for the business owners, for the product owners to understand what a developer inner dev loop is. If you look at how a traditional inner dev loop is, on a particular day, a developer could probably spend 6 hours a day developing, which is like 360 minutes. So a traditional loop is you start coding. 1 second, let me see if I can use a laser here. Just trying to understand how to shift my laser. Command L. Okay, this command L. L. Yeah, you got it. So okay, yeah. So sorry. So what happens is a developer starts developing. Like I told you, he might spend 6 hours a day developing, and 6 hours a day is 360 minutes. And the iteration of a loop or dev loop, you start the code, you build it, you start the code, you code something, you test it, you build it, and you inspect it, you find something, and then you again start your next loop of development, right? So if you see, they are if you roughly divide 5 minutes of iteration of inner development of 5 minutes of iteration in 360 minutes, which means you're doing 70 iterations of development, right? And one of these iterations could be successful, and then you commit your code. So the time that you commit your code probably could last for 10 seconds or 5 seconds or 10 seconds to 15 seconds, which means that is the tax that you pay, developer tax that you pay, which is very negligible for a 5 minutes of development loop. So in a containerized world, things are different. Things are very different because now you have to package your artifact, you have to containerize it, you have to tag it, you have to create your manifest files, you have to deploy it to the cluster and then test it. So roughly, if we are doing this on a CI/CD pipeline, it would say take 4 minutes for this, right? So the dev loop, the inner dev loop for now from 5 minutes, it is up to 9 minutes now. You can see, right? It's up to 9 minutes, which means whereas you had say 70 iterations that you did, and then finally release your code in a day, now you just have only 40 iterations, which means it is a 40% decrease in your potential new feature being released. Okay, so it is important that you fill the gap, right? And that is where I say it is important that people have local dev environments. Not just that, the other important feature or other important parameters that local dev environment addresses is, in this pandemic times, people have been working remotely from different parts of the world, and the power supply or the internet supply is not the same across the world, right? So the other idea is that people should be able to continue development irrespective of they being connected to the internet or not. Okay, which means you should enable them so that they can develop the whole thing. They have everything that is there in an environment on their local machine. Okay, of course it can't be the same for all the projects, or you can't do 100% satisfaction for a single project, but you can address it. It is possible, and I have experienced it in my own team. So you can do it with multiple tools like Draft from Microsoft, Scaffold from Google, Tilt, DevSpace, and Garden. And you have to club it with local Kubernetes clusters like Minikube and Kind and K3s. So on today's call, I'll be using Scaffold and Minikube. And we are also exploring possibilities of using K3s, which is putting a lightweight Kubernetes cluster on your edge computing. It could be a Raspberry Pi, something, so that you plug it into your machine, and the resources that the Kubernetes, your local Kubernetes consumes, is now loaded on your edge computer. I know edge computing is mostly used for IoT and other stuff, but we are thinking a little differently. We're trying this possibilities, and it is working. So that now it costs you, say, 50 euros or $50 extra, and with your laptop that is there, right? With your MacBook or the laptop that you already have. So now the whole resources that is there on the laptop is left to you and not to the cluster that is running. So the analogy that I like to use when I talk about local dev, now I'm moving my focus on personal dev environments from local environments. So local environment is where you have managed to run your code locally, where all your dependencies are running locally. You're not dependent on any environment. But now you're moving your focus to your personal dev environment, right? So what a personal dev environment again is, where, like I told you, you want to run a whole set of tests, right? It could be a security check, it could be a quality check, or it could be a compliance check on your own environment before it is merged to your master branch. And one more important factor that personal environments address is stepping on each other's toe, right? We are working remotely, half the team is working remotely, or 90% of the team is working remotely. You deploy something in your dev environment, and somebody else overrides it. Nobody is able to, you do not know who has overridden, you're frustrated, and your dev loop cycle is even expanding a little more now. And not just that, there might be cases where you want to spin up, share your specific feature to your UX team or to the product owner to take in feedback about the new feature. It could be a critical feature before it released to production, right? So these are interesting things that your personal dev environment addresses. An analogy that I would like to use here is living in a dormitory was having your personal dev environment. As a youth, I spent a lot of time in the dormitories. I had fun, but at the same time, the irritating things that happen in the dormitory where we step on each other's toes, things get stolen, and so many other things, right? So this is very important that you give a very peaceful environment for your developer to develop, as well as make it flexible for them to share their links to other to their colleagues or to the product owners to take feedback, and to have a peaceful and also to shift left all your activities that you want to do on your artifact on your personal dev environment, so that you're confident to merge it to your master branch before you release it. So what exactly is a personal dev environment? We have implemented this in a couple of projects that I have worked with. So what happens is you check in your code as soon as you check in your code. Once you're ready to deploy to your personal dev environment, what your dev environment looks like is something hyphen your name or your employee ID is actually your environment. Most of your CI/CD pipelines or tool or platforms has a unique ID for you, right? It necessarily need not be a unreadable ID, but every tool knows you, right? Because you're authorized and you're authenticated, it probably has your readable ID. So as a general practice, you use a readable ID as your suffix to all the infrastructure that you want, to the host, to the database, and everything. So you have your own environment, and your pipeline understands who is logged in, and it takes care of deploying it to your right environment. So now you don't have to step on each other's toe. Once you're happy with the code, then you merge it with the code because all your pipelines, all the stages in your pipelines are successful. So this is your personal dev environment. So imagine a developer having a local environment as well as a dev environment, okay, as well as a personal dev environment. As a platform team, it is important that you start developing your operations that you use in your pipelines as a pipe. Put it in a library or develop it as a CLI command. I'm not going to get into specifics of this, but as a platform team, you have to have reusable operations. CLI, you have to start thinking of how you can do CLI first. Automation first is one thing, but I would put it one step ahead and say that CLI first, right? Or you can make it available as a CLI command. So it is usable by the user easily, by the developer easily. So I would like to show a simple demo on Scaffold so that you understand how things work, for which I have to shift, stop sharing probably, and share my two and screen. Okay, so I hope you see my screen. So let's say, for example, I will have anything open. Okay, so let's say, like I told you, in the containerized world, there's a lot of things that your developer has to wait for before seeing is output, right? For example, let's say I'm the right project, so we have a program, let's say, which prints hello world in the console, right? So now, in a typical world, it's going to be very easy. Now, what I've done is I've imported all the dependencies and I've deployed my Minikube in my local environment. So now I'm detached from the internet. Just imagine that I'm detached from the internet, and I no more need internet because all my dependencies are running on my local machine. Okay. Now, what I do is I say Scaffold, 'fold' 'dev'. 'Dev' 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 You see now it is tagging first as it is built. It's a build application now, which is built artifact. Now it's getting tagged and it has been deployed to your local environment. It has created four things, right? It builds the artifact, it tags, it creates the manifest file, and it then deploys it to the environment. So this, if all these steps has to run on your CI/CD every time, it would take bare minimum 5 minutes to 10 minutes at least, right? Now you have shifted all of them to your local machine. So let's say I have to change this to and I'll save it, Control S. You see here, it's almost instantaneous. Of course, this is something, it might be annoying if you're doing frequent changes, but you have parameters or you have attributes which can stop you from doing it immediately. But that you can see the changes. It's almost few seconds. It's almost few seconds that the code that it took for the changes to reflect. This is a single project, but you can also imagine how it works for a microservices projects. Let's say you have a microservices where you have two services, and you just say scaffold dev here. We check the time. Okay. So yeah, it is now build artifacts. It is tagging. And it's creating the manifest files. And it gets deployed, right? So good. That is because you're starting for the first time. Both the services are identified because that's how I've configured it, so that you have two artifacts in place. It knows where those artifacts come from. So because I'm doing it for the first time, it identifies that all the artifacts have to be deployed, and so it has tagged, created the manifest files, and deployed. And now if I go to my application, it says hello world from app. So now what I do is I'm just modifying, let's say I'm just modifying one of my files in the one of the service, okay? Which means I'm trying to modify one of the service, and I'm not doing anything on the other service. Say again, I say and I say, right? So if you see here, Scaffold has identified that the changes has happened on only one service, and so it has picked up only that service that has changed. That it will pick up only that service that has changed. So it builds the new container. It then deploys it to Minikube that's running locally. A few more minutes, and it should be done. So it says, see, 13 seconds, almost 10 seconds, 15 seconds. So if you see here, it is just one artifact, it is just one service that has been affected. And if you go and see, the changes as reflected. So it is as simple as that. If you are a developer working in a containerized world, you will understand how much things are, how much things have been improved here, right? Right on your local machine. So once you're happy with everything, once your dev loops, once you're done with your iterations, say probably 40 or 50 iterations, now you're ready to check in, and only now you would need your internet to check in your code and merge it to the master branch. So let me share my screen again and move on to the screen one. Okay, it is early screen two. Okay, so that was Scaffold for you. Like I told you, you have many tools of that sort. You have draft, Scaffold, Tilt, DevOps, the Dev Space, Garden. Each of them has its own plus and minuses and its own features. For example, Draft does not support, it only supports Helm. Whereas Scaffold supports Helm as well as plain manifest YAML files. And so there are many differences there are slight differences between each other. So it is up to you to decide what suits you. On this call, I'm not going to get into details about the pros and cons of each of them, but the idea is to just create this awareness that these are available, and so that you can go back and see what is suitable for you and pick that for you, which suits you. Okay. So let me go to the next one. That was Scaffold. Um, So we talked about local dev environment. We use Scaffold to see how your local dev environment, Scaffold plus Minikube in my case, to see how it improvised the development experience. And then we saw how practically you can, develop or build a personal dev environment. We saw that. So, and next was how the next important parameter for me is to start thinking if you can give control planes for your developers, right? If you look into the first artifact, the stats that I gave you from the Dora report from Google, it clearly shows that improving developers' experience or empowering your developer with all these tools increases your DevOps maturity level, which in turn you can ship faster to the faster releases. You can ship your features faster, right? Sorry for that. So there are many tools that helps you to build a control plane. For example, Backstage from Spotify. You have Ambassador tool. You have Ambassador with really interesting concepts like interceptors. For example, you can debug if you have a very complex microservice, right? If you have a very complex microservice application, which say about 100 different services offer, which it's practically impossible for you to spin up the whole thing on your local machine. And when there is a need, you have to debug, right? So Ambassador has got really good interceptors to which you can you can spin up your service and let the request intercept to your service on the dev environment, so that the request comes to your local machine, right? You probably, most of you would remember remote hot deployments that we used to do from Eclipse, right? So similar things that you can do. Argo, so that you enable the developer to take ownership of their features. So right from your development to your production, so that the developer knows where his feature actually lies. Does it feature lies in the dev environment or the staging or the production? So Argo helps you do that. There's an interesting company called Humanitech in Germany which does that for you. I've seen their requirements. I've seen their product. It's pretty cool. So you have multiple tools or services which does that for you. But the idea is not to advocate or publicize any one of these, but it is to generate that awareness to show you that there are possibilities. Or if nothing suits you, I think it's time you can also start building your own little by little, right? It definitely helps the developers. I don't have a telepresence demo today. So this as such is what I wanted to show on the call today. I would want to leave the rest of the time for any questions that the audience have, and hope this session was quite useful for you. Yeah, this is all I can do for today's session, guys. Back to the
left.
Back to the left. Yeah.
Okay. Thank you so much.
Yeah.
Good. So we see a lot of advantages and goodies in what you just presented. I'm really tempted to consider it more and think about it even more. And I mean, at a very logical level, everything sounds so cool. It's about internalizing the things. How do you do that? I mean, it's like any habit, like any new thing. Like you understand it, you're convinced. Will I do it tomorrow? I don't know. what would be the trigger, or what's usually the trigger for people to start doing it tomorrow? Bit by bit, of course.
Yeah, I think the first thing is to focus on the local dev environments. That's the low-lying fruit because it doesn't need a lot of infrastructure, doesn't need a lot of engineering. The solutions are right there because if a particular project is already containerized, which means they have everything that is needed to be localized. They have the manifest files, they have the Docker files, and pretty much everybody would have been educated. Every developer would have been educated on Kubernetes, so they know how Minikube works. So the first thing is to see how you can localize your application, not the whole application, but your micro application. Right? That could be a good start. Number two is while your developers are doing that, the platform engineering teams should start uh, being liberal enough to give more namespaces on the cube. Say, for example, I am a Kubernetes platform owner, right? I am at the enterprise level. I have a Kubernetes platform where I have multiple tenants, a multi-tenant Kubernetes platform. So now I should start thinking that if a particular project demands, say, 20 namespaces, one each for this developer, right? I shouldn't shun away from that. I should be uh, I should be good enough to give as many namespaces that the team wants, right? Right. So that each developer has its own namespace, so that they don't step on each other's toes. First of all, because people are working remotely, they can't communicate as frequently as they can when they are next to each other. So platform teams should start thinking that it should start giving surplus number of namespaces. That's the second thing that they should start focusing on probably. And number three is or the on developer portals, on how you can improve developers to self-help themselves. Okay, a developer plane, right, a control plane for the developers. You have to start thinking from that angle, which is a long term, right? And so three things: one is your short term, one is your medium term goal, and one is your long term goal.
Got it. Makes sense. Yeah.
I'm gonna shift on the other side of the spectrum, and there are a lot of advantages clearly for doing this. Are there any drawbacks? For
Yes. Drawbacks is infrastructure. Number one that I can think of is your local machine. If you are talking about your 0 degree that I told you, right, that the downshift. When at that point it is the infrastructure because all of us do not have a super configuration. Ideally everybody should be in this modern technologies that we are using. Ideally everybody should be having a bare minimum of 16 GB, but God knows how when that will run out, because even if you run a mini cube or if you have a local cluster, probably it consumes at least 3 GB or 4 GB of your space. So that is where exactly ideas like having using edge computer attached to your laptop. So what you can do is your platform teams can engineer your edge computer and ship it to your developer. All they have to do is plug in and start. But that is a disadvantage. It's a long-term goal. You need budget, you need planning, and all those things. So that is one disadvantage. Number two is you can get easily lost in the sprawl of tools that you have. Right? You can start, you can get lost. You can do the POCs for the next 1 year, right? So and not make a decision at all, right? So rather don't get overwhelmed. Choose one or two, or you might fail, but start implementing them. It might take a couple of moments, but you don't get lost. Be conscious about not getting lost. So that is the two, or you asked me two or three. Or
well,
in
if you
general.
said three advantages,
Okay. These are the two basic disadvantages that I would see. Of course, there might be many challenges, but to start, right, the challenges that you would see to start is these two.
We've got another question coming from George. How can left shift be achieved for large systems? How do you handle dependency that won't fit on your local thing?
It's a very good question, and I understand a very large system. Like I told you, if you have a system where you have say 50 services or even 30 services, for you to spin up all of them on your local machine, or it's going to be a challenge. So there are multiple ways you can do it, certainly. For example, in one of the projects, what we did is, let's say project X, right? What we did is we said project X in a box. Okay, so we put that as one single project. What you do is you check that out and you run the automation script. It spins up the whole application on your local machine. But at the same time, we also gave the option for them to choose those services that they want through the automation scripts as an input. So only those services spins up. Of course, even after doing all these, or there might be projects which is really large or where you can't achieve this, where shifting downshift or zero degree won't be possible at all. So in that case, I would suggest that you start adopting personal dev environments at least, which is 45 degree probably on the protractor. Hope it answered your question, John.
Yeah. So I was thinking, so a while ago, not that far away in time, I would say, we still encounter situations where, when, I don't know, some companies were not using like a source control, you know, and everything was really to the left, I would say. I mean, I hope we won't get there, of course, back, you know. I mean, what's the minimum, you know, that we should keep, you know, out of this left shift movement? Like, it's the source control that needs to be right,
Yeah.
concise.
So what do you mean out of the shift left? Okay, what should not be in the shift left?
Yeah, exactly. I mean, hopefully we won't get the source control or anything similar. Just my local
Yeah,
PC, because we all know that it all works on our PC. It works on my PC for sure.
yeah. So things that you don't have to worry about keeping it on the left shift. For example, your performance testing. You don't have to worry about performance testing every time that you shift your code. You don't have to worry about compliance testing. Sometimes, there are companies who have some compliance to be tested every time. That you don't have to worry about that. Or for that matter, you don't have to worry about third-party dependencies, right? That you don't have to worry about. I'm dependent on the service which gives me the weather report, right? I don't care that you can't certainly shift to your left, right? So they are things. So it is logical, basically, that you can and you cannot do. There's nothing that you cannot do, but it is quite logical to decide if what to keep on your left and what to keep on your left.
Yeah, I mean, yeah, probably sometimes we just abuse, you know, the abundance of resources out there in the cloud and everything.
Yeah.
In the meantime, we could easily do it.
Yes.
It's about the choice. Then I
It's
told
choice.
you.
It's choice.
Yeah, and what I think, it's a journey. So make small steps. I think that was your message.
Make
Everybody. Make small steps incrementally, and then you'll get to a certain, let's say, degree to the left that you're comfortable with.
Yeah. Yes, absolutely. Small draws makes the ocean. So take small steps. Don't be overwhelmed. Absolutely fine. Take your time and do it.
Yeah.
All right. Well, thanks a lot, Anish. It was a pleasure chatting with you.